now that this is glued into your notebook, I need you to go to the top. Well, your notebook's like this. Turn it sideways and go up to the top of the page. I need you to write down slope. So some of you have heard before that slope is equal to rise over run. You may have even heard that slope is equal to y2 minus y1 over x2 minus x1. Sorry. y2 minus y1 over x2 minus x1. So now we're going to learn what that means and how to apply it to graphs. So let's start with, what is a positive slope? So if you look at that flap, example 1 says find the slope of the line shown below. Well, first of all, this line right here is positive. As we read in English, we go from left to right. So as I read this, I'm going from left to right. Example 1, find the slope of the line shown below. We read a graph the same way. We go from left to right. And if we go from left to right and the line is increasing or going upwards, then it has a positive slope. How do we determine what this slope is? So remember, we said that slope is equal to rise over run. So if we look at our graph and we go from one point to the next, starting from left, going to the right, we need to look and see how much it goes up from this point to that point and how far it goes over. The over part is the run. So to get from this point to this point, we need to go up 1, 2, 3, 4. We're going to go up 4 because we go up, we have a positive 4 over, and then the run is how far we need to move to the right. And we are going to the right 1, 2. Go to the right 2 spaces. So the 4 goes on top because that's the rise. The 2 goes on the bottom because that's the run from left to right. We just need to reduce our fraction now. 4 over 2 is 2. So the slope of that line is 2. Example 2. Find the slope of the line that passes through the points below. So we've got the points 5, 2 and 4, -1. If you look up here, I also wrote down that this is a slope equation. y2 minus y1 over x2 minus x1. So let's go ahead and label these points. We'll say that this is x1, y1, and that this is point x2, y2. So now we just need to plug them in to this equation. So I'll rewrite that equation down below. Slope equals y2 minus y1 over x2 minus x1. Now I actually forgot to tell you something at the beginning. Slope is also represented by the letter m. So sometimes you're going to see people write that this equation, or rise over run, is actually equal to m. So now let's get back to plugging in our values for this equation. Our y2 was 4. Our y1 was 2, so minus 2. Our x2, oh, sorry about that, I made a mistake. Our y2 is actually -1. And our y2 is 2. Our y1 is 2. Our x2 is +4. and our x1 is 5. So you should have negative 1 minus 2 over 4 minus 5. So this is again where order of operations comes into play and knowing how to add and subtract with negative numbers. Negative 1 minus 2 is negative 3. 4 minus 5 is negative 1. And negative 3 divided by negative 1 is a positive 3. So for the second example, our slope, or m, is equal to positive 3. Okay, so let's move on now to negative slope. So we're going to start by finding it on the graph. Find the slope of the line shown below. So first we want to go ahead and again write down that slope, which is the same thing as m, is equal to rise over run. So if we look at this graph reading from left to right, we go from this point up here to this point down here. So we're actually going down as we go from left to right. Our rise is actually going down, so we say it's a negative. It goes down 3, so that's a negative 3. And it goes to the right 2. The only number that's going to be positive or negative that you have to worry about is the rise. If it goes up, it's positive. If it goes down, it's negative. The run, always right is positive. So if I go down 3, that's a negative 3, and then I go over 2, that fraction cannot be reduced. So this actually is the answer. Our slope is negative 3/2. I told you fractions were going to be in this unit a lot. Example 4. Find the slope of the line that passes through the points below. So we've got the points 0, 6, and 5, negative 4. So again, we're going to rewrite this equation so that we remember how to do it. We have that m equals y2 minus y1 over x2 minus x1. So if I label this x1, y1, x2, y2, so I make sure I plug them in the right spots. It does not matter which point I label 2 and which one I label 1. As long as x1 and y1 are in the same coordinate point and x2 and y2 are in the same coordinate point, everything's fine. This could be x2, y2, this could be x1, y1. It doesn't matter. My y2 is 5. My y1 is 6, so minus 6. My x2 is 5. And my x1 is 0. So now we just need to evaluate that. 5 minus 6 is negative 1. 5 minus 0 is 5. So again, our slope is then negative 1/5. So as you can see on both these examples, we end up with a negative number. If we have a negative number, we're going to have a negative slope. And we can expect our line to be going down as we read it from left to right. Now we're going to take a look at zero slope. Find the slope of the line shown. So again, we're going to do that slope equals rise over run. So as I go from left to right, I'm going to start with this point. I don't have to go up or down at all to get to the next point. So that's a 0. I do not go up or down at all. My run, to get from here to here, I have to go to the right. 1, 2, 3, 4, 5. So my run is 5. Well, 0 divided by 5 is just 0. So our slope is 0. What kind of line is this too, by the way? This is a horizontal line. So if you have a 0 slope, you need to remember that you have a horizontal line. Example 6. Find the slope of the line that passes through the points below. 0, 4, and negative 3, 4. So again, I write my slope equation, m equals y2 minus y1 over x2 minus x1. I'm going to call this x1, this y1, this x2, this y2. If I plug these in, my y2 is 4, my y1 is 4, so 4 minus 4. My x2 is negative 3, my x1 is 0. 4 minus 4 is 0. Negative 3 minus 0 is negative 3. But 0 divided by negative 3 is 0. So again, our slope is 0. And this would also be a horizontal line. The last case is no slope. So we're going to find the slope of the line shown below. Again, slope is rise over run. Well, if I look at this graph, to get from this point to this point, I have to go up 1, 2, 3, 4, 5. So I'm going to go up 5. I guess, or I could say that I'm going from this point to this point, down 5. Either way, it doesn't matter. There's a rise of 5. Doesn't matter if it's positive or negative. Because the bottom, the run, I don't have to go left to right to get from one point to the other. So our run is 0. Well, remember, you cannot divide anything by 0. It's not allowed. If we put that into the calculator, we get an error. So we say that this is undefined. Undefined. If you're dividing by 0, it cannot happen. It is undefined. Undefined slopes occur when we have vertical lines. So this is a vertical line. Sorry, I spelled that wrong. Vertical. V-E-R-T-I-C-A-L. Number 8. Find the slope of the line that passes through the points below. So again, we have m equals y2 minus y1 over x2 minus x1. I'm going to call this one x1, y1, x2, y2. My y2 is negative 2. My y1 is 2, so that's minus 2. My x2 is 5 minus my x1, which is 5. If I evaluate that, negative 2 minus 2 is negative 4. I'm getting more negative. And 5 minus 5 is 0. I cannot divide by 0. So again, this slope is undefined. Alright, so that's all the notes we've got for slope. Please go ahead and attempt the worksheet on slope as well for homework tonight, and we will talk about it more on Friday. See you then.